Okay, so I'm not going to spend a ton of time talking about these because you have the answers, but I am going to just talk a little bit about where I'm getting everything. So remember recursive, if you notice on all four of these, recursive always has two parts, your starting value, and then f of n equals f of n minus 1, and then at the very end is always your pattern. So notice if it's multiplying, you write that. If you're adding or subtracting, you just write it as addition or subtraction. So you always need to know your starting value and the pattern. If the pattern is multiplying, then we called it geometric. If you're adding or subtracting, that's where we got the arithmetic on numbers 2 and 3. And then the explicit formula is you always do your start and then your pattern. And remember, your variable goes with your pattern. If it's geometric, then your variable is an exponent. So in the two geometric ones, in 1 and in 3, you've got an exponent there. And then if it's arithmetic, then your variable is just a regular variable. You're just multiplying the pattern and the variable as opposed to the variable being an exponent. So just notice kind of how those are set up. And remember, to get the 0 value, you just have to make the pattern go backwards so that you can figure out what the original value was. Okay, we did one of these in class today. We already did question 5. Remember, if it's R, that this is geometric, and this is going to be really clear in your test tomorrow, so don't stress too much about remembering D versus R. So here I've got a pattern that says I've got 2, and then I'm multiplying by -2 every time. So I'm just going to show you kind of what the pattern is. 2, -4, 8, -16, blah, blah, blah. So if I want the 0 pattern, instead of multiplying by -2, I have to divide by -2. So -1 is my starting point. And remember, we want to write explicit. So that means I'm going to have f of n equals my starting value. The pattern is to times by -2, and that is all going to be to the n power. And they want me to say the 12th term, so all I'm going to do is plug 12 in there. -1 times -2 to the 12th. The reason I'm using parentheses is just because this is a negative number. You just always want to make sure exponents go on the outside of parentheses. So that's just something that you would plug into your calculator. And you should get -4,096. So make sure that I did that right. You should get that answer. In class today, we said this is one that would be easiest to use, or all of these are easiest if we make a table first. So I would make a table here to say my starting point is 15, and then if you read, that says that's your pattern, is to add 3 every time. So my pattern is to add 3, so that means I'm going to have, if I go ahead and fill in my table, 1, 2, 3, 4. All right, if I add 3, that gives me 18, 21, 24, 27, and I could keep going, but after I hit 20, really nothing else fits on the graph. So I just plotted the ones that fit. On 9, remember 2 here is your start. 3 times 3, that says times 3, that's your pattern. So I'm going to say my starting value is 2, and then I'm going to multiply by 3. So 2 times 3, this is the patterns times 3, so 6. 18, 54, and notice I can't even fit 54 on there, so I just fit the first 3 points that I could fit. That's all you're doing on those problems. Okay, most of this sums is in your calculator as far as, so you really just have to practice punching everything in correctly. The equation to remember is S of n equals A 1 minus r to the n over 1 minus r. So we have to say A, which is our starting value, -1, R, which is the pattern, so this right here is being multiplied by -3, and then N, which is how many terms there are. And if there's no ... you can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 terms. All right, then you're just plugging into your equation. So I'm going to say S of n equals A, -1, 1 minus, make sure you always put r in parentheses, just like I said on the previous page, 1 minus negative 3. And I even wrote that wrong. Instead of n right there, I should have written that the exponent was 9. And now you're just typing it in. Just make sure that when you type these in, you should do the top separately, turn it into a fraction, the bottom separately, turn it into a fraction. Just do one step at a time so you don't have too many parentheses going on, and you should be able to get this value, negative 4,921. 12, we did 13 together in class. 12 is very similar, except because of the dot, 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 you have to continue the pattern. So you have to continue pattern so that you can see how many terms there are. So we still know that A is negative 12, and you should see you're dividing by 2. Remember, you have to write it as a fraction. You have to write it as multiplication. So instead of divide by 2, we're going to write that as 1/2. And then my n, I just have to keep my pattern going until I get to that value. So you could use your calculator to do that. I can make a little list for you. You've got negative 12, negative 6, negative 3 over 2, negative 3 over 4, negative 3 over 8, negative 3 over 16. These are the values your calculator would give you. And that is 1, 2, 3, 4, 5, 6, 7. I have 7 terms. So when I set up my equation, I'm going to have negative 12, 1 minus, always use parentheses, 1/2 to the 7th power, all over 1 minus 1/2. All right? You're going to have to just take some time with your calculator and make sure that you can get this final answer of negative 381 over 16. Okay, we did 13 together in class today. Remember, the exponents that you always want 0 as an exponent. And then if it's a fraction, you want the exponent negative 1. So on 13, we wanted the exponent negative 1. On question 14 here, we don't want that because we don't have any fractions that we need to flip. So to make our exponent 0, I'm going to use x as negative 1. When I plug in, that's going to give me 5 times 2 to the 0 power minus 2. Anything to the 0 power is 1, so 5 times 1. That's 5 minus 2, that gives me 3. So that's where I plotted this point, negative 1, 3. And then I wanted my value to be positive 1, and to get that I could plug in 0. So 5 times 2 to the positive 1. That's just 5 times 2, which is 10. 10 minus 2 is 8. So that gives me the point 0.08 that I've plotted. And remember, it's just got a curve towards this asymptote. Oh, I didn't say that. The asymptote, remember, is coming from the last value. That's where I get the asymptote. Domain is always all real numbers. And here my range, negative 2 is the lowest it could be. And if you notice, it's going up forever. So that's going to be to positive infinity. All right, very similarly here, I want my first exponent to be 0. So that would be if I plugged in positive 2 into this exponent. All right, so if I do that, I've got negative 4 times 2 to the 0 plus 2. Anything to the 0 power is 1. So negative 4 plus 2 is negative 2, which is why I plotted the point 2, negative 2. And then now, because this is not a fraction, I don't want to flip it. I want it to stay the same. So I do want the exponent positive 1. So to get that, I'm going to use x is 3. So that's negative 4 times 2 to the first power plus 2. That's just negative 4 times 2, so negative 8 plus 2 is negative 6. And if you'll notice, I plotted the point 3, negative 6. It's got a curve towards the asymptote. And again, I didn't say anything about the asymptote. That's coming from this plus 2 right here. Domain is always all real numbers. This time, my range is going down forever. So it's going to be negative infinity. And the highest it could possibly get to, even though it's not actually going to get there, is positive 2. So that's why my range is kind of written the other direction now. Okay, last slide. We're just going to be doing equations here. You all think these word problems are pretty easy, so I just want to make sure you all have everything. Remember, A is my first value. here is my R. We have to write it as a decimal place, so we got to move the decimal twice, so that's 0.15. And because it's growth, this is going to be 1 plus. All right, so my equation here would be y equals 70,000, parentheses 1 plus 0.15 to the, we can say to the x power, and then you just want to look in the table to be able to answer the question, how many will there be in 3 hours? All right, same idea on 17. We did that one together. Well, some of you weren't paying attention, so I'll talk about that one. All right, we've got A. Decreasing means I'm going to do 1 minus, and then rate of 7%, move the decimal twice, so 0.07. So I've got y equals 230,000. 1 minus my rate, because it's decreasing, to the x power. And again, we're going to use our calculator and the table to answer the question. On this one, though, pay attention. If you're starting in 2008 and you're going to 2016, you want to look at 8 in the table, because that's how many years have passed. You can't look at 16. You want to look at 8. All right, the question about Kurt. So 50 is my A. We're earning, so that's increasing. That's 1 plus. 10% is 0.10 as a decimal. So I've got y equals 50, 1 plus 0.10 to the x. And then we just look in our table to answer the question, when will it reach 300? Last one, Mikkel is buying a car, so we've got A. It's depreciating, so that's 1 minus. Percentage, move it 2 decimal places, that's 0.075. All right, so I have enough to write my equation now. Y equals 35,000, 1 minus 0.075 to the x power, and then we'll just use our table one last time to answer, when will it reach 10,000?